as I plug these things in to this, then what happens is I get my 3 still stays. Then I get 3x squared minus 2y. And then I square my a, so I get 9x to the 4th plus opposite sign. 2 times 3 is 6, x squared y. And then finally plus and square the last one, and I get 4y squared. And that becomes my solution. So that's what we got to do when we get cubes, is again, you want to watch and make sure that you get your stuff in there of where you need those, okay? So that's cubes. So anything else with that part? And then 6.5 was just throwing it all together. 37 questions, all tossed in, all different factorings and different stuff that you need to do with that. So how do you feel? Do you think you're okay with stuff and ready to do this test on Monday? Or do you want to put it off until after Thanksgiving? That's the big issue. If we put it after Thanksgiving, we got a problem. So what you could do is do it after if you wanted to, just on your own time. Okay, do you think you're ready? Okay, yeah, because again, you're not having to think about it over Thanksgiving and stuff. So that's your best bet, I think, is to do that with it. The last section, the 6.6, is taking a look at solving quadratic equations. Everything up to this point has been expressions, because all we've been doing with it is factoring it and pulling it apart and coming up with what our values would be for it. And so we've kind of broke it apart and come up with those. But in this case, within this quadratic equation piece, is the only difference is that now you're going to have x squared plus 5x plus 6 is equal to 0. So we're going to set it equal to 0. So it's going to have a value. So now what we're going to look for is we're going to use all the factoring skills we just had used, and we're going to factor this thing on this side. So what does it factor to? So x and an x, factors of 6, things that multiply to give me 6, that add to give me 5. So what would I end up with? What times what gives me 6? That adds to 5. 2 and 3, And because it's both pluses, I put pluses in there. And right now, what we did is, if we looked at this just as that, all it is factoring. We just factored it, okay? So the only difference today that we're going to do is, now that we factored it, we're going to take each of the factored pieces and set them equal to 0. And when I set them equal to 0, I'm going to minus 2, and I end up with x is equal to a negative 2. And in the other one, I'm going to minus 3 and find x equals a negative 3. And what these are 2 solutions that cause this thing to work. So if I check it, and I put a negative 2 back in where x is at, so I have a negative 2 squared plus 5 times a negative 2 plus 6, it's going to equal 0. 2 times a negative, or negative 2 times a negative 2 is 4. 5 times a negative 2 is a negative 10. And sure enough, 4 minus 10 is a negative 6, and a negative 6 plus 6 is 0. So it worked. And if I plug 3 in, I have 3 squared plus 5 times it's a negative 3 plus 6. It should also equal 0. Negative 3 times negative 3 is 9. Negative 3 times 5 is a negative 15. 9 from 15 is a negative 6, and a negative 6 plus 6 is 0. Okay? Now, in intermediate algebra, we did a whole chapter on quadratic equations, but some of ours that we had didn't factor, so we couldn't work with, or we had to come up with a different way of working with them, and that was the quadratic formula, which of course we don't have. But what this is telling me is I have a graph, And my graph is coming through and forming what's called a parabola, and that's what it's making. And what we have just found is where it crosses the x-axis at. So it's crossing the x-axis at a -2 and a -3, because each of these are x-intercepts. And you don't have to remember, of course, that, but I just wanted to show you how it ties in with what we're going to do next semester when all of you are in my intermediate algebra class. So that's how that ties in and what you have happening with it. So those are my pieces that I have with it. Okay, so that's solving quadratic. So let's do some more of these. Because again, all it is just factoring stuff and coming up with what your solution would happen to be for those. So some they factor for you already, like this one. So if it's factored for you, all you simply have to do, as long as it's equal to 0, if it's equal to something else out here, and we'll talk about those in a little bit, we have to multiply this together or FOIL it together and move that number over. But because this is equal to 0, all I need to do is set each piece equal to 0 and solve them. So here I'm going to add 7 to both sides, and I get x equals 7. Here I got a little more work involved because I need to add 2 to both sides. Then divide by 3 and find x is equal to 2/3. So in my answer in Hawks, it'll ask me for both of these solutions. So it's going to ask me for 7 and it's going to ask me for 2/3. So we want to make sure that you put those things in there so that you end up with those values when you're working with them. So that's that kind that's already solved for you. What do you think? Get that piece? So again, it's just one step. It's not a new step. We did this back in chapter 2. Chapter 2, we solved for x, and we got what x was equal to. So that's kind of just doing a good review. Sometimes they give them to you that look like this. And if it's in that format, I have to get it so it's set equal to 0. So that means I need to minus 35 from both sides. And I get this for my solution. So now I can factor it. So what does this one factor to? So I get x and x. Factors of a -35 that add to 2 in the middle. So sign-wise, I know one's negative and one's positive, and the positive piece has to be bigger because that's what it's showing me up above. So what are factors of a -35 that give me 2? A positive 2? 5 and 7. So 5 is negative, 7 is positive. Then set each equal to 0. And solve for x. So add 5. Subtract 7. And I get my 2 answers of x equals 5 and x equals a -7. Okay. So not hard. It's just remembering that you got to set it all equal to 0 to come up with what your solutions happen to be. Now it may say the solution set. If it says the solution set, then I would list these as -5 or -7, 5 inside of braces. So it's if it asks for a solution set. So sometimes they do, sometimes they don't. I don't think they always want a solution set like that. I don't know if it's always in that format. It might not be. We might have to take a look and see what they come up with in there with those. But I think sometimes it isn't, sometimes it is. Okay. How about this one? 8x squared plus 16x plus 8 equals 0. So if you look just at the left-hand side, factor it. So what can I do with this whole thing? 8, 16, and 8. I can take an 8 out. Okay. Then does that factor? So what would this factor to? X and an X. So really this is 8 times x plus 1 squared. Or really I only have one thing, because if I set both of these equal to 0, what happens? They're both identical, right? So I minus 1, so I get x equals a negative 1. And over here, if I minus 1, I still get x equals a negative 1. So really, there's only one solution to this. Now, the 8 out in front, you might look at that and say, well, but wait a minute, what do I do with that 8? The 8 has only increased it and made it 8 times the size it should be. It doesn't change my answer. It's not something I have to set equal to 0, because if I set 8 equals 0, that's not true. Okay, so the 8 is just kind of sitting out there. Now, if you pulled out an 8x, then that's a little different story, because then you got to set that thing equal to 0 to come up with what your solution would end up being for that. Okay, how about this one? 3x cubed minus 9x squared minus 12x equals 0. So let's see what we can do with this thing, if we can factor it or not. So first, can we take something out? What can we pull out? Well, 3, 9, and 12, we can pull out a 3. X cubed, x squared, and an x. So I can pull out an x. That leaves me with x squared minus 3x minus 4 equals 0. So then, does that factor? So what does this factor to? So again, x and x. Negative 4 means one's negative and one's positive. The 3 in the middle is negative, so that means my negative factor needs to be bigger. So what are some factors of a negative 4 that add to a negative 3? Negative 4 and a positive 1. But now when I pulled out this 3x, it's got an x with it, so I need to set each piece equal to 0. And so when I do that, I have to solve here too. So I can divide by 3, gives me x equals 0. I need to add 4. And then I need to subtract 1. So my answer comes out to be x is 0, x is a negative 4, or positive 4, and x is a negative 1. So if you had set notation of what your solution set is, it's negative 1, 0, 4. Kind of try to put them in order from smallest to largest when you're putting your set solution together for what your answers would be. Okay? What do you think? Yes, no, maybe. Just one extra step. That one extra step is now we're setting it equal to 0 to come up with what your solution would be for those. Not always do they have everything on one side, and so you might find that you need to get it set equal to 0. So your steps with this one is move everything to one side, getting the equation equal to 0. Step 2 is factor the one side. Step 3, set each factor equal to 0 and solve for the variable. And then finally, check it. So we're going to make sure those work. Make sure it gets us back to 0. And you're going to check it in the original problem. So we're going to go back and we're going to make sure it comes out and it's going to end up equaling what they gave us. So here's an example of one of those. X squared minus 9x plus 1 equals a negative 7. So it's not set equal to 0, but I need to get it there. So I need to add 7. And I get that. Can that be factored? So does that factor? So factors of a positive 8 give me a negative 9. Means both must be negatives because a negative times a negative is a positive. And I need to add to a negative 9. So things that multiply, that give me a positive 8, but add to a negative 9. So the only factors, negative 8 and a negative 1. Set each equal to 0. And find x. I'm going to add 8. X is equal to 8. I'm going to add 1. And x is equal to 1. So now I need to make sure they work. So that's where my check comes in. Plug 8 back into the original. So 8 squared minus 9 times 8 plus 1 should give me a negative 7 if I did it right. 8 times 8 is 64. Negative 9 times 8 is a negative 72. 64 and a negative 72. What does that leave me with? 8, I think. Negative 8. Gives me negative 8 plus 1 is a negative 7. So, yep, that works. Plug 1 in. One squared is 1. 9 times 1 is negative 9. 1 and a negative 9 is negative 8. Add 1 gives me a negative 7. So I know I did my math correctly. So you can check those and know whether you did it right. Okay, so be careful and make sure you get stuff set equal to 0 when you're working with those. Questions with that one? Again, get your 7 over and make sure it equals out to what you happen to need for those. Okay, another one like that, I can find one in here. Yeah, I can't find one in here. Yeah, I don't have one. They kind of limit me in what I've got. I guess they don't do that to those. How about this one? X squared plus 5x plus 1 equals 7. Work it through. We'll see what you guys end up with. So I'm going to minus 6. minus 7, sorry. You get a minus 6. We were thinking ahead of the game there, I guess. Yeah. Mm-hmm. Yep. So x minus 1 equals 0. And so finally, add 1. X equals 1 minus 6. X equals a negative 6. And does it work? So 1 squared plus 5 times 1 plus 1, does it equal 7? 1 squared is 1. 5 times 1 is 5, plus 1 does end up being 7. 1 plus 5 is 6, plus 1 is 7, so we're good there. And then a negative 6. Negative 6 squared plus 5 times a negative 6 plus 1, does it equal 7? Negative 6 times negative 6 is 36, plus 30, or minus 30, my minus in there, plus 1. 36 minus 30 is 6, plus 1 does end up equaling 7, so we must have did something right. Okay, so what do you think? Again, it's factoring, but you got to make sure it's set equal to 0, so don't forget to get it set equal to 0. That's a big key to that thing, is getting it set equal to 0. On some of these, the other thing that they do is they start you out with x equals 4 and x equals 5. So they might give you that for your answers. And now they're going to say, okay, put it back into what the quadratic equation happened to be. So if I do that, the reverse of what I did over here, notice what I did, and we're going to work it backwards to come back with what we have. So they're giving me these answers. So I need to subtract 1 from each side, so I get x minus 1. I need to add 6 to each side, so I get x plus 6. Then you get to this point, and you FOIL it back, and you get it back to the equation. Okay, so we're kind of going backwards up these things instead of going from where we start with. So if I have x equals 4 and x equals 5, to get it back to its binomial, I'm going to minus 4 from each side. Okay, so I'm kind of reversing what I did. So to get it back to a binomial, I needed to do that piece. Over here, I need to minus 5. So I get x minus 5 equals 0. So I'm kind of working backwards. So what does this give me? Well, now it gives me 2 binomials that I can FOIL. X times x is x squared. X times a negative 5 is negative 5x. Negative 4 times x is negative 4x. And finally, a negative 4 times a negative 5 is a plus 20. And combine my middle terms. So x squared minus 9x plus 20 equals 0. So I get it back to its quadratic. Okay, not hard. Just reverses stuff, comes back where you started at, and then goes back to the other with that. So how about another one of those? X equals a negative 3 and x equals 5. So what's this one going to become if I take it back to a quadratic? Okay, so this piece, we need to go back and we need to reverse it. So I'm going to add 3. So I get x plus 3 equals 0. I'm going to subtract 5. So I get x minus 5 equals 0. So now my two binomials are those. And then I use my foiling to multiply it back. X times x is x squared. X times a negative 5 is negative 5x. 3 times x is a plus 3x. 3 times a negative 5 is a negative 15. Put my middles together. And I get that for my answer. Okay. So that's basically what's in that section, is going back through and doing those things. Yes?
There's a problem. I just hit practice.
Okay. Yeah. 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 Well, let's put it up here.
16x squared equals negative 20x. So I think it's just confusing.
Okay. All right. Yeah, but it doesn't have a middle term. So what you need to do is get it set equal to 0. So I can get it set equal to 0 by adding 20x to both sides. So I get 16x squared plus 20x equals 0. Then I need to look at this and say, how can I factor that? What can I do? What can I pull out of here that lets me factor it? So we've had those. We had those in 6.1 where you just had that piece and that's all you had. So what could I pull out of it? Well, 16 and 20, I can pull out a 4. X squared and x, I can pull out an x. So what's it going to leave me with? Well, it's going to leave me with 4x plus 5 is equal to 0. And then set each piece equal to 0. So 4x equals 0. 4x plus 5 equals 0. And divide by 4. So I find x is equal to 0 for the first one. Second one, minus 5. Divide by 4. And I find x is equal to a negative 5/4. Okay. Does that help? So basically on the left-hand side, you can have any kind of stuff that we factored before. You could get any kind of thing in there. Now they will not put cubes in here because they're not quadratics. Cubes are their own little entity and they do their own little stuff, where quadratics, all quadratics are only to an x squared, okay, or an x to the 4th or an x to the 6th. Anything even gives you basically a quadratic type equation. So they'll never put those in there. So this kind of is what they have, okay? So, oh, no, well, it depends on what they ask you for. If they ask you for the solution set, then I would have to write this as negative 4/5, comma 0. It depends on what they write it as. Mm-hmm. Yeah, but we use braces because we're looking at set notation. Set notations between braces. Where we had brackets and we had parentheses when we did interval. Yeah, it's a little different because it's set notation. Mm-hmm. Yep. It's saying each of these could be my possible answers to this. So if we plug these guys back in and check it, put 0 into your original. Don't go back to anything you factored. So I'd have 16 times 0 squared is equal to a negative 20 times 0. 0 squared is 0. 0 times 16 is 0. Negative 20 times 0 is 0. So that side's all gone. Then if we do this other one and plug the 5/4 in, negative 5/4. If I square negative 5/4, I get 16 times negative 5 times negative 5 is 25, and 4 times 4 is 16. These cancel, gives me 25. So then on this side, I gotta see if I get 25. Well, 4 and 20 will cancel. Negative 5 times a negative 5 is 25. So guess what? My two answers work. Okay, there's solutions for this. And so that's what comes out of that. Okay, thanks for finding that one in there. I did not have that one, that variety in my notes, but I'm going to now, because I put it in there. Okay, so now it's been added in, so we know what we got to do with that one. Okay, so basically the only thing that's different with this section than the others is that you're getting it set equal to 0. Still factoring just the same as we've been factoring in there. Okay, so factoring has been the same stuff that we've been going through and doing. Anything else? You think you're okay, or should we do some more? What do you guys think? More? Not more? Or we can do more without putting it on tape, because I think I've got enough stuff that's in there. So let me get this thing turned off. And